So for this lesson, we are going to be using the algebraic interval and set builder notation from the previous lesson to state the domain and range of graphs. This is something that you're going to be expected to be able to do for the rest of this school year, so please make sure that you are listening carefully and that if you have questions, make sure you're reaching out and getting them answered. So just a quick review: domain and range of a continuous graph, which actually any graph really and truly. Your domain is the x values from left to right. So you always start with as low as you can go and move up to as high as you can go. And so that is left to right for domain. With range, you have the same strategy. Start with as low as you can go and go up to as high as you can go. And that is actually going from down to up on your y-axis. So for this particular function, we have to state the domain and the range in all three types of notation. So we're going to take this graph and I'm going to look and see how far I go to the left. And that is 1, 2, 3, 4, 5, 6, 7. So I go to -7 on the x-axis, and then I go up to 1, 2, 3, 4, 5. So 5. So in algebraic notation, this is going to be -7 is less than or equal to x, which is less than 5. And I'm using less than 5 because I have an open circle on that value. And then for range, we are now looking at how far down we can go and then how far up we can go. So we're going down to -3 and we are going up to 1. So our range is going to be -3, which is less than or equal to y, which is less than 1. So your interval for your domain, you're going to have a bracket on -7, and then you will go up to 5 and it will get a parenthesis because it is not included. Then your range is going to go down to -3. It also will get a bracket because it's filled in. And then you will go up to 1 and it will get a parenthesis. Now for set builder notation, you are going to use a squiggly brace, and then you will have x is such that, so draw the big line, and then you're going to write the inequality that you used for algebraic notation. -7 is less than or equal to x, which is less than 5. And then your set builder notation for your range, you're going to have that brace, and then since it's range, you're going to use y is such that -3 is less than or equal to y, which is less than 1. So for our next graph, we're still going to write our domain and range in all three sets. So we'll start with algebraic, and since I don't have any arrows, I'm going to assume that this continues to go out forever. So for my domain in algebraic notation, that is just going to be all real numbers. And then for my range, that is also the case because we go down and up forever. Well, as an interval, we are going to have parenthesis and then -infinity to +infinity because we can go down forever and up forever. That is also going to be true for the range. Now for set builder notation, we are still going to use our fancy brace, and x is such that, And then we are going to have all real numbers. And then for our range, we will have y is such that we have all real numbers again. Okay? So now let's go ahead and look at a graph that has some limitations. So in this case, we actually have a limit in the domain because we have this parabola and it can only go to 0. It can touch the 0, but we can go to the right, but not any further to the left. So in algebraic notation, this is going to be x is greater than or equal to 0. And then for the range, we have no limit for how far we can go down. We have no limit for how far we can go up. So this gives us all real numbers. So our interval for our domain, we are going to have a bracket on our 0, and then we can go to the right forever. So that is going to be infinity with a parenthesis. And then for our interval on our range, that is going to be negative infinity to positive infinity. For set builder notation, we will have our brace, and x is such that x is greater than or equal to 0, and close those braces. And then for our range, we will have y is such that it is all real numbers. So then for our next graph, we have a line segment here. So again, we are going to look at how far we can go to the left for our domain. It looks like -1, and then how far we go to the right. So that is 5. So in algebraic notation, we will have -1 is less than or equal to x, which is less than or equal to 5. And I have less than or equal to because both ends are filled in circles. Now for our interval for these values, we'd have a bracket and the -1. We go up to 5 and it also gets a bracket. So then for set builder notation, we're going to have our brace. We have x is such that -1 is less than or equal to x, which is less than or equal to 5. Now for our range, we are going to look at how low we can go. So we can go down to 1 and we can go up to 7. So for our range, we have 1 is less than or equal to y, which is less than or equal to 7. And so we have a bracket. We have the 1, and then we go up to 7, so it also gets a bracket. So for a set builder, we have y is such that, and we are going to bring down that algebraic notation. So 1 is less than or equal to y, which is less than or equal to 7. So for algebraic notation on this next graph, this one is a little bit interesting because we do have that open endpoint, and then we also have the hump that is over here. So in our domain, we can go to -3 on the left, and then we can go up to 1 on the right. So we'll have -3 is less than x, which is less than or equal to 1. And then for our interval, since we can't touch -3, it's going to get a parenthesis, and then we're going to go up to 1. Now for set builder notation, we have x is such that -3 is less than x, which is less than or equal to 1. And then close our brace. For our range, this is going to be a little bit different. So we can go down to -4. But if we look at this end only, it looks like 0 is not included in our set. But if we go all the way across, we do have a point that 0 is defined. And so that makes it where we can include 0 as part of our range. So we can go down to -4. So we have -4 is less than or equal to y, which is less than or equal to 0. So then we are going to have as an interval a -4. And then you need to go up to 0. And it will get a bracket since we can include 0 here. So even if you can only include it in one spot, it still counts. So definitely make sure you look all the way across and know which values have no way to include them. And then for set builder, we have our y is such that -4 is less than or equal to y, which is less than or equal to 0. And for our last graph, we actually have a graph that has two pieces to it. So this is going to cause a change in some ways that we have to write our range. That's where it's really going to come in at. So for our domain, if we look all the way across, then we're going to look at this break and make sure that all values are covered. And so where we have an unincluded value down here for our x's at 0, we actually have an included value up here. So 0 is still included, just like we talked about on the last graph. So our domain here is actually -infinity to +infinity because we don't have a break. So actually that is our interval. And so our algebraic notation is actually all real numbers. So then our set builder is x is such that it is all real numbers. And then for our range, now our range is going to be a little bit different because as we go down to the bottom, yes, we can go all the way down, but then when we go up to 0, we don't have anything in between 0 and 1. So for our algebraic notation, we're going to have the y is less than 0 or y is greater than or equal to 1. This leaves out all the values between 0 and 1. So as an interval, we're going to have to use that union of sets. So we will have -infinity to 0, and that gets a parenthesis. And then we'll write that u, and we will have 1 with a bracket to +infinity. And of course, any infinity gets a parenthesis. So in set builder notation, we will have y is such that y is less than 0 or y is greater than or equal to 1.